Hello everyone and welcome to my channel. Today we are diving into Unit 1 of the Internet of Things, one of the most exciting and transformative technologies of our era. I am Parth Patil, CSI Division, roll number 11. In this session, we'll cover four big topics: what IoT actually is, how its architecture is structured in four layers, the key protocols that make devices communicate, and finally, some real world applications that are already changing our lives. So, let's get started. Today's agenda. Before we jump into the content, let me quickly walk you through what we will be covering today. We start with the basics, what IoT actually means, then we move into the architecture, understanding how IoT systems are structured. After that, we look at the protocols, the languages, devices used to talk to each other. Then we explore applications across different industries. And finally, we'll briefly touch on challenges and the future of IoT. This is a well-rounded overview of Unit 1. So stay with me. What is IoT? So, It's actually, its core, the Internet of Things is about connecting everyday physical objects to the Internet so they can send and receive data. Think about it. Your smartwatch tracking your heartbeat, a thermostat that adjusts temperature automatically, or a factory machine that alerts engineers before it breaks down. All of these are IoT in action. The three pillars are sensing, which is about collecting real world data, connectivity, transmitting that data wirelessly, and intelligence, make smart decisions using the data. IoT isn't just a technology, it's a whole new way of thinking about a physical and digital world working together. So, what are the key characteristics of IoT? First, interconnectivity. Anything can be connected anytime, anywhere. Second, IoT provides thing related services while respecting constraints like privacy. Third, heterogeneity. Devices from completely different makers and platforms can still work together. Fourth, IoT system handles dynamic changes. Devices constantly join or leave the network and their state like location or battery keeps changing. Fifth, the enormous scale. We are talking about billions of devices, which is the massive engineering challenge. And sixth, safety. Both data security and the physical safety of users are critical. These six characteristics define what separates a true IoT system from a simple connected device. Coming to the IoT architecture. Great. Now that we understand what IoT is, let's move on to its actual structure. IoT structures follow a layered architecture, just like how the internet has layers such as physical, network, transport, and application. IoT also has its own architectural model. We'll be looking at the four layer model, which is the most commonly used framework to explain IoT systems. Here is the IoT four layer architecture, which I want you to understand thoroughly because it forms the backbone of every IoT system. Starting from the bottom, layer 1 is the perception layer. This is where physical interaction happens. Sensors, cameras, RFID readers, and the actuators are all part of this layer. They sense the environment and collect data. Layer 2 is the network layer. Once data is collected, it needs to travel somewhere. This layer handles all communication using Wi-Fi, Zigbee, Bluetooth, cellular, or LoRa, which depending on the use case. Layer 3 is the middleware layer. This is the intelligence engine. It processes, stores, and analyzes the data, often using cloud platforms like AWS IoT or Azure IoT. Layer 4 is the application layer, the part the end user actually sees. This is where dashboards, mobile apps, and automated control systems live. Remember, data always flows from operator to physical sensors to user facing applications and appliances. Perception layer, that is the layer 1. Let me go deeper into this. The perception layer's job is to sense the environment. Sensors are the eyes, ears, and nose of an IoT system. They take physical phenomena like temperature, light, or motion and convert them into digital signals. On the right, you can see common sensor types we encounter in IoT projects. Temperature sensors like DHT11 are very popular in beginner projects. PIR sensors detect motion. GPS gives us location data, and RFID and NFC are used for identification, like in contactless cards. Remember, The perception layer also includes actuators, devices that take actions like turning on a motor or switching a light. So this layer is both input and output. Coming to the IoT protocols. Just like humans use different languages in different situations, you text a friend differently that you would write a formal mail. IoT devices also use different protocols depending on what they need to do, how far they need to communicate, and how much power they have. Key IoT protocols. Here are the six most important IoT protocols you need to know for this unit. Starting with application layer protocols. MQTT is the most popular IoT protocol. It follows a publish subscribe model. Devices publish data to a broker and subscribers received. It's extremely lightweight and works even on 2G networks. COAP is similar to HTTP but designed for constrained devices. It uses UDP instead of TCP, making it even lighter. HTTP is the protocol we use on the web, not the most efficient for IoT but useful when integrating with existing web systems. For the network wireless layer, Zigbee is used heavily in smart home devices. Your smart bulbs and sensors likely use it. Z-Wave is similar but operates at a sub-gigahertz frequency, giving it better wall penetration. And LoRaWAN is perfect for applications needing very long range with very low power, like monitoring farm equipment across kilometers. MQTT. It is the most important IoT protocol. It follows a three-component model: publisher, broker, and subscriber. A sensor, say a temperature sensor in your room, publishes data to a topic like home temperature. A broker, which is essentially a message server like Mosquito or AWS IoT Core, receives that data. Then any application or device that has subscribed to that topic receives the message. This publish subscriber model is brilliant because the publisher and subscriber don't need to know each other. They're completely decoupled. Now MQTT is also three quality of service levels. QoS 0 is fire and forget. Fastest but no guarantee. QoS 1 ensures delivery at least once. QoS 2 guarantees exactly once delivery. Slowest but most reliable. The right level depends on your application's needs. Now, coming to IoT applications. Now, for the most exciting part, we'll start with the IoT applications that are theoretical, that it stops being theoretical and it rather starts becoming more real. IoT is already transforming industries and our lives in ways we may not even notice. Let's look at major applications. Some of the four major applications of IoT in these domains are smart home. It is one of the most visible IoT domain. Your smart bulbs, robot vacuum, voice assistants, all IoT. These devices make our lives more convenient and energy efficient. Healthcare IoT or IoMT is rapidly growing. Wearables like smartwatches can now detect irregular heartbeats. Remote monitoring means doctors can track patient vitals without the patient being in the hospital. Smart agriculture is transforming farming. Soil sensors tell farmers exactly when and where to water crops. This reduces water wastage and increases yield significantly. Industrial IoT or IIoT is perhaps the most economically significant. Predictive maintenance alone saves billions of dollars by detecting machine failures before they happen. Each of these domains relies on the same IoT architecture and protocols we just studied, which shows why understanding the fundamentals matters the most. Challenges and future of IoT. The biggest one is security. When you have billions of devices connect to the internet, many of them cheap with minimal computing power, securing them all is incredibly difficult. IoT botnets have already caused major internet outages. Interoperability is another headache. Your smart bulb from brand A might not work with the smart hub from brand B. The industry is still working towards common standards. Scalability and power management are engineering challenges. How do you manage millions of devices efficiently? And how do you power sensors in remote locations for years? But here's the exciting part. The future looks amazing. 5G will supercharge IoT. Edge computing will make systems faster and more intelligent. And when you combine AI with IoT, which we call AIoT, you can get systems that don't just collect data but learn, predict, and act autonomously. Digital twins and smart cities are no longer science fiction. They are being built right now. Coming to the key takeaways. First, IoT is a network of physical objects embedded with sensors and connectivity to exchange data. It's not just about gadgets, it's a paradigm shift. Second, the four-layer architecture gives us a clear mental model. Perception collects, network transmits, middleware processes, application presets. Third, protocols are the communication standards. MQTT for lightweight messaging, COAP for constrained devices, and wireless protocols like Zigbee or LoRaWAN for different range and power needs. Fourth, application span smart home, healthcare, agriculture, and industry, all built on the same fundamental principles. Fifth, the future is even more powerful. 5G, edge, AI, digital twins, and smart cities are coming fast. Make sure you understand all five of these forms. They form the foundation of everything else we'll study in this subject. Coming on to the last slide. We covered a lot of ground today, from the definition and characteristics of IoT. Though it's a four-layer architecture, key protocol, the MQTT and Zigbee, all the way around the world, is an exciting future ahead. I hope this gave you a strong foundation for understanding IoT. This subject is incredibly relevant. The industry is booming and the skills you're building here are in huge demand. If you have any questions, you can comment down below and let me know, and I'll be happy to answer your questions. Thank you for watching, and I'll see you back